Hello, everyone, and welcome. Today, we're diving into an interesting topic. What is a string? This is the first slide of our presentation, and I'm excited to guide you through this concept. We'll explore what strings are, why they matter, and how they're used in programming. So let's get started and discover the basics together. All right, let's move on to slide 2, which covers the initialization of strings. When we talk about initializing strings, we're essentially discussing how to create and assign values to string variables at the moment of declaration. This is a fundamental step because it sets the foundation for how we work with text data in programming. You can initialize a string by assigning a literal value directly, like using quotes around the text you want to store. It's important to understand that the way you initialize your strings can influence how you manipulate them later on. This slide is crucial because understanding proper initialization helps us manage memory efficiently and avoid common errors. Throughout this presentation, keeping these basics clear will make working with strings much smoother as we delve into more complex functions and operations. Welcome to our discussion on strings. So, a string is essentially a sequence of characters, like letters, numbers, or symbols, that we treat as a single data item. Think of it as a bunch of characters grouped together to form meaningful text. Now, in programming, we usually represent strings as a character array. This means that each character in the string is stored in a specific position within an array, making it easy to access and manipulate. Understanding this concept is fundamental because strings are everywhere in programming, from displaying messages to processing user input. Recognizing that a string is just a character array helps us see how data is organized behind the scenes, enabling us to work more effectively with textual data throughout the rest of this presentation. Let's talk about how to declare a string in C. The syntax involves using the keyword char, followed by the name of the string variable and the size of the array in brackets. For example, if I write char name5, this means I'm creating an array called name that can hold up to 5 characters. The key point here is that the size of the array determines the maximum number of characters you can store, including any special characters like the null terminator. This is important because it directly impacts how much data your string can hold. Connecting this to the overall theme, understanding how to declare strings properly is fundamental since strings are such a core part of programming, especially when dealing with user input or text processing. All right, let's talk about how we initialize strings in C using character arrays. Essentially, there are 2 main ways to do this. First, you can initialize a character array by explicitly listing each character like this. Char greet10 equals H, E, L, L, O. When you do this, the compiler automatically adds a null character at the end of the string, which is crucial for indicating where the string ends. The second way is to initialize the array directly with a string literal, such as char greet10 equals hello. Here, the compiler not only stores the characters, but also takes care of the null terminator at the end. You can also write it more simply as char greet equals hello, and the compiler will determine the size automatically based on the string length plus the null character. Understanding these initialization methods is important because they affect how memory is allocated and how strings are handled internally. This connects to the overall theme of managing strings efficiently in C, which is fundamental for writing effective programs. Let's talk about string storage now. As you may already know, we commonly use 2 standard functions for handling input and output in C, scanf and printf. These functions are quite versatile and form the backbone of most console-based programs. When it comes to working with characters and strings, they utilize format specifiers, specifically %C for individual characters and %S for strings. Using %C allows us to read or print single characters, which is useful for character-by-character processing. On the other hand, %S is designed to handle strings, enabling us to input or output entire sequences of characters. This connection between format specifiers and string storage is fundamental because it directly influences how we read and display text data in our programs. So, understanding these functions and their format specifiers is key to managing string data effectively and building more interactive and user-friendly applications. let's take a closer look at this example to understand input and output in C programming. First, we declare an array of characters called color with a size of 6. This will hold our string or character data. Next, notice the print statement where we use %C to write a single character. Here, we're passing the address of color, which might seem a bit unusual, but it's meant to demonstrate outputting a character. Then, we recall from Chapter 2 that we've already seen other input and output functions like getchar, puchar, gets, and puts. These are fundamental for handling characters and strings in C. Moving on, we see scanf with %C, which is used to read a single character into our variable. After that, we have print with %S, which outputs a string, and scanf with %S, which reads a string into our array. The key takeaway here is understanding how these functions work together to handle input and output for both characters and strings. They are essential tools in C programming, especially when dealing with user interaction. Remember, the main concept is that we use format specifiers like %C and %S to indicate whether we're working with characters or strings, and we need to be mindful of passing the correct addresses. This example helps connect all these pieces together, reinforcing how input and output functions are fundamental to creating interactive programs. Now, let's take a look at some built-in string functions that are really useful when working with text in programming. First up is strlen, S1. This function simply returns the length of the string S1, but it's important to remember that it excludes the null character, which marks the end of the string internally. So, if you want to know how many characters are in a string, strlen is your go-to. Next, we have strcat, S1, S2. This one is handy for concatenating two strings. It takes S2 and appends a copy of it to the end of S1, then adds a null character to mark the end of the combined string. The function also returns the modified S1, so you can chain operations if needed. Moving on, there's strlwr, S1. This function converts all the characters in S1 to lowercase. It's particularly useful for case-insensitive comparisons or standardizing user input before processing. Finally, strcmp, S1, S2 is a comparison function. It compares S1 and S2 and returns a negative value if S1 comes before S2 alphabetically, a positive value if S1 comes after S2, and 0 if they are exactly the same. This is fundamental for sorting or checking string equality in a way that accounts for lexicographical order. These functions tie into our overall theme of efficient string handling. Knowing them allows us to manipulate text more effectively in our programs. Let's now explore some more built-in string functions that can really make our programming tasks easier. First up is strcpy, which allows us to copy the entire string S2 into S1. Remember, this operation modifies S1 directly, so it's useful when you need to replace or initialize strings. Next, we have strncmp. This function compares the first n characters of two strings, S1 and S2. It's quite handy when you only need to compare a portion of strings, perhaps for prefix matching or partial searches. The comparison result is similar to strcmp, indicating whether S1 is less than, equal to, or greater than S2. Then there's strcmpi. This function compares two strings but ignores case differences, so uppercase and lowercase characters are treated as equal. This is particularly useful for case-insensitive comparisons, like user input validation where case shouldn't matter. Finally, we have strupper, which converts all characters in a string to uppercase. This can be useful when you want to standardize string data, for example, before performing comparisons or displaying uniform output. Overall, these functions expand our ability to handle strings more flexibly and efficiently, fitting seamlessly into our broader goal of mastering string manipulation in programming. Now, let's take a look at some additional built-in string functions that can really enhance your programming capabilities. First up is strchr, which stands for string character. This function helps you find the first occurrence of a specific character, C, within a string, S1. It's useful when you need to locate a character quickly. Next, we have strrchr, where the R stands for reverse or last. This function finds the last occurrence of a character C in the string S1. It's particularly handy when the same character appears multiple times and you need to find the final one. Moving on, SDR is a powerful function that searches for a substring, S2, within another string, S1. It returns a pointer to the first occurrence of S2 in S1, which is very useful for pattern matching or extracting specific parts of a string. Finally, there's SDRev, which simply reverses the string S1 and returns the reversed version. This can be helpful in various applications, such as palindrome checking or data manipulation. Overall, these functions provide versatile tools for string processing, allowing you to efficiently locate characters, find substrings, and manipulate string data, all of which tie back into our broader theme of mastering string functions to write more effective and concise code. Now, let's take a look at some additional string functions that can really enhance how we work with strings in our programs. First up is SDRtalk, which stands for string tokenize. This function searches within a string, S1, for tokens that are separated by delimiters we specify in S2. Essentially, it helps us split a string into parts based on certain characters, and it returns a pointer to the first token found. It's a powerful way to parse data or input that's structured in a particular way. Next, we have SDRnset. This function allows us to modify the first n characters of a string, S1, by setting them to a specific character. See, it stops when it encounters a null character, which marks the end of the string. This is useful when we need to overwrite part of a string without affecting the rest. Then there's SDRset, which is similar but more straightforward. It sets every character in the entire string, S1, to a given character. See, it continues until it hits the null terminator, effectively replacing the whole string content with a single character. Finally, we have scanf. Unlike the previous functions, scanf is about reading input. It divides lines into tokens based on format specifiers, making it very handy for parsing structured input from strings. Whether you're extracting numbers, words, or other data types, scanf helps you break down a line into manageable pieces. All these functions tie back to our overall theme of manipulating and processing strings efficiently. They give us versatile tools for searching, modifying, and parsing strings, which are fundamental tasks in programming.